How do language models segment their internal experience of the world of words in order to progressively learn how to interact with it more efficiently? Our neurocognitive study of artificial intelligence focuses on the phenomenon of synthetic categorical restructuring, a process through which each successive perceptron neural layer abstracts and combines relevant categorical subdimensions from the thought categories of its previous layer. This process shapes new, even more efficient categories for analyzing the synthetic system's unique experience of the external linguistic world to which it is exposed. Categorical cutout is the synthetic process by which a neuron in layer n+1 extracts a specific categorical subdimension from the category of each of its precursor neurons in layer n, with which it is strongly connected. Cutout is thus the mechanism that allows each neuron in layer n+1 to distinguish and create a new categorical form, a new thought category of its own, emerging from an indistinct background composed of all the thought categories of its antecedent neurons. Categorical cutout generates the synthetic phenomenon of synthetic categorical restructuring. At each new neural layer, new artificial thought categories are created through original selections and recombinations of categorical subdimensions extracted from the thought categories of the previous layer. But how does this particular mechanism of categorical restructuring function in more detail and concretely? To better understand what synthetic categorical restructuring is, consider an example from the first two perceptron layers of the GPT-2XL language model. In layer 0, the neuron involved can be associated with the thought category legal concepts, meaning that this neuron is expected to detect this category. This category can be decomposed into 5 categorical clusters of tokens. Legal terms, containing the token's patent, liability, arbitration. Accusations, involving the token's allegation, accusation, disputed. Claims and charges, associated with the token's billing, claim, charge. Legal actions, relevant to the token's lawsuit, sue, embroiled litigation. Legal roles, including the token's defendant, lawyers, plaintiff, claimant. Among these initial tokens, some also activate the receiving neuron in layer 1, charges, claims, accusations, allegations, alleging. These tokens thus contribute to shaping the category of this receiving neuron. These specific tokens have been cut out from the precursor category to form part of the target category. These tokens constitute the categorical subdimension legal allegations extracted from the source category. Notably, this categorical subdimension legal allegations is not merely a selection of one of the categorical clusters, legal terms, accusations, claims and charges, legal actions, legal roles, within the source category legal concepts. Instead, this categorical subdimension results from an active categorical cutout process, which selectively extracts and groups certain tokens originally belonging to different categorical clusters. This unique and original categorical subdimension therefore contributes to a categorical reconstruction, meaning that in the receiving neuron, a new categorical segmentation of the token world objects is being created. This synthetic mechanism, extracting a new categorical subdimension, occurs for each initial thought category. Each of these categorical subdimensions in turn becomes one of the categorical clusters of the receiving neuron, which in this case belongs to the category unverified assertions. Consequently, as categories transition from their initial form to their associated target category via categorical cutout, we witness authentic categorical restructuring carried out by the receiving neuron. In the following sections, we will present 2 major types of categorical restructuring performed by neural networks. Synthetic categorical attention occurs when, during its categorical restructuring process from layer n to layer n+1, a receiving neuron focuses more attention on certain precursor categories to form its new thought category. This results in a process of categorical complementation, which consists of adding to this target category a categorical subdimension extracted from a precursor category. This extracted subdimension is semantically distinct from other categorical subdimensions extracted from the rest of the precursor categories. Here is a map of the example which will follow. For example, the receiving neuron in layer 1, associated with the category cultural and social context extracts, through complementation, 3 semantically complementary categorical subdimensions from its precursor neurons in layer 0, Latin American and Spanish names and places, extracted from the precursor category, cultural geography, containing the tokens Argentine, Luis, Juan, Puerto, Nicaragua. Employment and roles, cut out from the precursor category, categorical data, involving the tokens transfer, incub stint. Football teams and roles, abstracted from the precursor category, sports entity names, including the tokens goalkeeper, relegation, Cardiff, Southampton. Synthetic categorical phasing occurs when, during its categorical restructuring process from layer n to layer n plus 1, a receiving neuron extracts categorical subdimensions from multiple precursor categories that are semantically correlated. This manifests through a categorical intersection process, where the same tokens, acting as categorical echoes, are jointly extracted from source categories and simultaneously present in the outline subdimensions. Here is a map of the example which will follow. For example, the receiving neuron in layer 1, associated with the category unverified assertions, extracts through intersection 3 semantically linked categorical subdimensions from its precursor neurons in layer 0. Speculative claims, extracted from the precursor category, document elements. Legal allegations, outlined from the antecedent category, legal concepts. Speculative claims, derived from the previous category, linguistic elements. These categorical subdimensions share a set of common tokens. We will now illustrate two typical examples of categorical cutout. Firstly, the categorical cutout of the semantic type. In the example that we see, the constitutive tokens of the categorical subdimension A1, enhanced modifiers, extracted from the category linguistic elements of the precursor neuron, are homogeneous from a semantic point of view. These tokens are indeed hyper, super, turbo. This categorical subdimension A1 is well fabricated and not simply passively identified from an intrinsically pre-existing semantic subgroup. This subdimension is indeed semantically well distinct from the possible categorical clusters of this neuron: proper nouns, abbreviations, capitalized words, compound words, prefixes. And this subdimension is also semantically distinct from the categorical background, not extracted, of the starting category, a background that it is possible to segment through the following three left clusters. The left cluster, A, prefixes, constituted of the tokens altern, os, counter, subst. The left cluster, B, superlative terms as comprising the tokens superflu, superhuman, superpower, superior, supers. The left cluster, C, variants and modifiers, are constituted of the tokens mini, daub, dual, extra, triple, sub. The categorical cutout can also be of the graphemic phonological type. In the new case that we present here, the tokens of the categorical subdimension A1, variations of B, extracted from the category lexical patterns of the precursor neuron, are homogeneous from a graphemic and/or phonological point of view. These tokens are indeed B, bow, bess, bi, beaver. The tokens forming the categorical subdimension A2 vowel combinations, cut out from the category categorical nomenclature of the precursor neuron, are homogeneous from a graphemic and/or phonological point of view. These tokens are AE, EA, IE, EEE. Finally, the tokens of the subdimension A4 Germanic sound patterns, issued from the category linguistic elements of the precursor neuron, are coherent at the graphemic and/or phonological level. This subdimension contains the tokens die, be, and lie. Here is a map of the example which will follow. To conclude, let us examine an illustration of the categorical restructuring process. From an initial precursor neuron associated with the thought category current affairs, the categorical subdimension A1 disasters and threats is cut out. It contains the tokens Qaeda, nightmare, malware, ransomware. We observe how these tokens have been selectively extracted from at least 4 of the 5 categorical clusters through which the initial category can be described: health, political figures, entities, technology, and criminal activities. Another categorical subdimension, A2 magical and mystical elements, is extracted from the precursor neuron belonging to the synthetic category symbolic elements. This subdimension includes the tokens Spiral, Scourge, Ginny, from Ginny Weasley, a character in Harry Potter. These tokens have been selectively extracted from at least 4 of the 5 categorical clusters through which the initial category can be segmented: spirituality, names, jewelry and gems, and weapons. Within this categorical restructuring process, the cut-out categorical subdimensions we have just mentioned, A1, disasters and threats, and A2, magical and mystical elements, can form categorical clusters of the new category associated with them in Layer 1. This new superordinate synthetic category, named here catastrophic phenomena, can then be described alongside 3 other categorical clusters. Cluster 3, natural disaster, consisting of the tokens kalam, catastrophic, pandemonium, Katrina, turmoil, kavak. Cluster 4, aggressive entities, including the tokens malicious, ferocious, insurgents, demonic, Taliban, devils, jihad, rebel. Cluster 5, emotional states involving the tokens stirred, messed, raging, mad. Thus, before our eyes, a synthetic categorical restructuring has just taken place. From an initial Layer 0 categorical segmentation, primarily structured around the synthetic thought categories, current affairs, and symbolic elements, a new original artificial category, catastrophic phenomena, emerges in Layer 1, whose gradual genesis we have just partially traced. Our genetic neuron viewer, available in the description of this video, enables visualization of the synthetic categorical restructuring phenomenon that occurs during the transition of all neurons from perceptron Layer 0 to Layer 1 in GPT-2XL.